Hi guys, we're going to move forward into section 31-1. We're going to talk a bit about polygons. So you might have done a little bit of this in previous classes, but it's always a good thing to review. The word polygon is not very clear in the video, but it will be. Poly means many, and gon means sides. So we're going to be talking about figures with different numbers of sides, and I promise it will clear up at some point. That's just how we roll here. What I did learn in a video I just did was that if I zoom in a little bit, it doesn't freak out as much in the focusing. Now, it'll probably prove me wrong. So we're going to go through the names of certain types of polygons and then some characteristics of them, and then I'll walk you guys through examples in our assignment. So we're going to start off with a 3, and I'm just going to do the number of sides over here on the left-hand kind of red side to the left of the red line. So we're going to do 3, 4, 5, 6, 7, 8, 9, 10, and there's more, but we'll call it good. So a 3-sided figure, you guys know this. It's a triangle, tri like tricycle, meaning 3. 4 sides is a quadrilateral. 5 sides. Do you guys know what 5 sides is? I think you do. I think you do. You need to think about it. You know it. Pentagon. 6 is hexagon. Do you guys know what 7 is? 7 is heptagon. I'm betting you guys know 8. You know it. Think about it. What has 8 legs and lives under the sea? Now I want to watch Finding Nemo. An octagon. Anyone know 9? I want to make sure I'm going to spell it correctly. Come on. Yep, I had that right. Non-a-gon. I always want to put an E instead of the A, like a nun-gon, but that wouldn't be right. 9 is nonagon. It's kind of fun to say. Try it out loud. Do it at dinner. Number 10, decagon. And yes, there are others. We're just going to call that good for the moment. If we need to do something else, we'll add it to the list. So there are certain characteristics of polygons. I'm going to attempt to draw this guy, my hexagon, because that's one that I can kind of draw relatively well. So I'm going to mark this in a very particular way. Notice that I'm giving every single one of the sides its own little tick mark. That means I'm telling you the sides are all congruent. And 1, 2, 3, 4, 5, 6. Hexagon, 6 sides. If all of the sides are congruent, that means all of the angles are congruent. And that means that we have a regular polygon. So that regular polygon means all congruent sides, however many there are depending on the list, and all congruent angles. So that is what it means to be regular. Next, oh, by the way, I might have to tell you if it's a regular polygon if I'm drawing it myself, because you know my abilities don't exist. But if you're looking at something on our worksheet, you'll know. You'll be like, yeah, that looks good, or Bishop drew that. So you'll know. The next thing that we need to talk about is the concept of concave versus convex. Come on. There we go. So concave, I want you guys to think about that ending portion, that suffix of the word cave. So a cave is like something you can go into. It might have a bear or it might have a treasure. I don't know. But think of cave. So I'm going to draw you guys a picture. This is an example of a concave polygon. What that means is that we can connect any 2 vertices out here outside the polygon. Oh, please focus. Please stay like that. So that's why it's concave, because the polygon kind of creates its own cave. Convex, and I'm not attempting to make this regular, but I kind of just go straight to my good old standby of the hexagon. if I attempt to connect any of those, and I guess I shouldn't say any two, it's any vertices outside, well, if I connect this vertex to anywhere else that it's not already connected, I'm staying within the figure. So convex means that the connections occur within the figure between vertices. Concave means that you can connect the vertices outside the shape, and it creates like a little cave entrance. So I'm going to pause, and I'm going to work through a few of the evens, and then we'll come back to some more examples in just a second. So this first one, number 2, you might be arguing, well, I think it's a square. I don't know, it's not labeled. You might be saying, it's a rectangle. I don't know, they look like 90 degrees, but I'm not going to measure it. But I think we can very confidently say that this is, that's an A, a quadrilateral. It's got 4 sides. Okay, this guy, 1, 2, 3, 4, 5, 6, 7. 7 sides, heptagon. Problem number 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, I'm kind of distracted. My dog is lying on her bed on the floor to the right of me, and she's dreaming, and her little feet are just going flip, 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 flip. Must be a happy dream. She must have gotten the squirrel that she's been trying for 3 years to catch. That squirrel's mean. So this guy has 10 sides. 10 sides, deca, like decade, decagon. So the next set asks you, is it concave or convex? I'm going to grab my highlighter. If I can connect 2 vertices outside, that guy is concave. I say the cave. This one, convex. And then on number 12, it asks if it is in focus. It asks if it's regular or not. Not. They're not all the same size. Number 14. Scoot that so you guys can see that. Also, not regular. They're not all the same length on the sides, and the angles are not all the same. So I'm going to transition back to my note paper, and I'm going to scoot it down to the bottom. We're going to talk about 2 more ideas, do a couple of things, and then run through some more examples in this video and get you guys 16 through 24. I know that this is a little bit longer of an assignment because you guys are going to be doing 1 through 23 odd, but come on, naming a polygon does not take as long as doing something like Pythagorean theorem. So while the length of the assignment looks long, like the speed, you guys are going to zoom through this. So the next thing that I want to address with you is to talk about the measure of all the angles in a polygon. So when I'm talking about the measure of all the angles, what we're going to do is we're going to find the sum, which means to add them all up. So if we think about a quadrilateral, we remember that that has 360 degrees. When we think about a triangle, that has 180. Not that you can see that because my screen is blurry. So let's think about a pentagon. Definitely not regular. Like, you guys know I can't draw, but that's just how my world rolls. But if we think about a pentagon, it's going to have 5 angles. They might be all congruent if it's regular. They might be different if it's not. Here's how it works. I'm going to give you guys a little formula. It is n minus 2, n means the number of sides, times 180 degrees. And we're going to walk through how that works for the quadrilateral, the triangle, and the pentagon. So think about the quadrilateral. We have 4 sides. 4 minus 2 is 2. Times 180. So 4 minus 2, number of sides minus 2, times 180. Well, 2 times 180 is 360 degrees. It works. Think about your triangle. We have 3 sides, minus 2. The minus 2 is part of the formula. Times 180. Well, 3 minus 2 is 1. Hey, that matches. So let's look at our pentagon. So a pentagon has 5 sides. I have to go minus 2 and then times 180. 5 minus 2 is 3. 3 times 180, yes, I'm reaching for my calculator, I don't want to do wrong, is 540 degrees. It should be more than the quadrilateral because it's got more angles to it. So that should hopefully kind of make some sense. I'm going to transition to do a couple problems on our assignment, in particular 16 and 18. So it says find the interior sum. That means find the total of all inside angles. We can do that. We just have to count. So number 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This guy has 11 sides, if that would focus for us. I'll throw you guys some extra credit if this would focus. I'm sorry. You know I hate my equipment. Okay. It'll work, I hope. I'm going to throw you guys some extra credit. If you can find the name of an 11-sided polygon, you can submit that in the little chat feature in your Google Classroom assignment when you upload your photo, and I'll throw you some extra credit. Okay, so 11 sides. We're going to take 11 minus 2 times 180. Well, 11 minus 2 is 9. 9 times 180 is 1,620 degrees. That's for all 11 angles added up. So let's do number 18. This guy's going to be a decagon because it has 10 sides. So we'll have 10 minus 2 times 180. So 8 times 180 is 1,440 total degrees. So there's that set. Well, now I need to transition us to talking about the last set on our assignment, which deals with the measure of one interior angle in a regular polygon. So let me write that down. For us to find the measure of one interior angle of a regular polygon. Now I'm going to highlight the word regular. Remember what regular means. Regular means that we are going to have congruent angles and congruent sides. So whatever shape we're looking at, all the angles are the same. So I'm going to go back and I'm going to draw my bad hexagon. My bad hexagon. So this guy's a hexagon. I need you to pretend that it's regular so all the sides are the same. So let's find the measure of one interior angle. Well, first I got to find all the interior angles. So the sum of all interior angles, that's that formula we played with before. So n minus 2 times 180. So 6 minus 2 times 180. That's 4 times 180. I think that's 720, but I want to make sure. It is. That's the total of all the angles. But we want just one angle. Well, how many angles are there? There's 6. It's a hint. It's a hexagon. There's 6 angles. So we're going to take that 720 and we're going to divide by 6. And that means that just one angle is 120 degrees. So there is a formula that we can use for this. If we want one interior angle of, and it's got to be regular, they all have to be the same, of a regular polygon, what we can do is take n minus 2 times 180 to find all of them, and then once that's done, divide by the number of angles total, divide by n. So I'm going to walk you guys through how to do 20, 22, and 24. Oh, good Lord, how many sides are on number 20? 12. So we have a 12-sided polygon. Oh, I'll toss you another extra credit point if you give me the name, the official name of a 12-sided polygon. Don't say 12-sided polygon. I won't give you credit for it. Look it up. Google it. You can find it. So we need to find the measure of one interior angle. So I need to find all of the angles first and then divide it out equally amongst the 12 angles. So I can type it exactly like it looks. 12 minus 2 times 180 divided by that 12. And we are looking at 150 degrees for each one, once this focuses, each one of those interior angles. Okay, so the next one, number 22, you might be like, wait a minute, I should know this. Yeah, you kind of should, but that's okay. We can walk through it in different ways. This is a regular polygon, so all these sides are the same. It's a square, so we have a total of 360, and you're like, how'd you get that? 4 minus 2 times 180 divided by 4. Each one of these guys has to be 90 degrees. I could see how you could reason your way through that and be like, I don't have any work to show, Bishop, it's just 90. And I would have to agree with you. Plus, you can't see anything anyway on my screen. Please focus. Okay, there we go. So the last one, number 24, I really hope my screen does not give you guys seizures. I'm worried about it. 1, 2, 3, 4, 5, 6, 7. So we have a 7-sided polygon. So 7 minus 2 times 180 divided by the number of sides, which is 7. When you guys divide by 7, you don't always get the prettiest of values. 128 point, it says round to the nearest tenth. I'll call it 6 degrees because it's not exactly pretty. And you guys will notice that I typed it twice. I'm like, is that right? Yeah, that's right. Okay, guys, I miss you. Take good care of yourselves. Bye.